Have you ever wondered how the universe speaks? Its language is mathematics. This is not merely a grand assertion, but a fundamental truth. Mathematics is a universal language, an all-encompassing medium that transcends cultural and geographical boundaries and forms the backbone of our understanding of the universe. It's everywhere, whether we realize it or not. It underpins the rhythms of music, the patterns of nature, and even the structure of our own DNA. It's the invisible force that describes the swirling of galaxies, the ticking of a clock, and the path of a thrown ball. In the vast, captivating landscape of this mathematical universe, abstract concepts and precise calculations converge, unlocking secrets and deepening our comprehension of the cosmos. As we embark on this journey, prepare to see the world in a whole new light. Numbers, simple yet profound, are the building blocks of the mathematical universe. They form the foundation on which all other mathematical concepts are built, each one a unique entity with its own characteristics and relationships. From the simplicity of integers, whole numbers without any fractional component, to the complexity of irrational numbers that can't be expressed as a simple fraction, numbers paint a fascinating picture of the mathematical landscape. Even the humble zero, with its ability to represent both nothingness and the additive identity, holds a special place in the numerical realm. Delving further, we encounter the mysterious world of prime numbers, those integers greater than 1 that have only two distinct positive divisors, 1 and themselves. Herein lies the beauty of numbers, in the relationships they form, the patterns they create, and the problems they pose. Numbers, in their simplicity and complexity, weave the intricate tapestry of mathematical concepts. Enter the world of shapes, where mathematics acquires a visual dimension. Geometry, a branch of mathematics that studies shapes and their properties, provides a tangible way to understand our surroundings. It is as if the universe itself speaks through geometric language, and we are simply trying to decipher it. To start, let's consider Euclidean geometry, named after the ancient Greek mathematician Euclid. This form of geometry is probably the one you're most familiar with. It's the realm of flat planes, straight lines, and perfect circles. It's all about angles, areas, and distances. A world where the shortest distance between 2 points is a straight line, and where right angles are always 90 degrees. This geometry forms the basis of many structures we see around us. Think about the blueprints used in architecture, the grid lines on a map, or the trajectory of a soccer ball. All of these are examples of Euclidean geometry at work. But the universe isn't limited to flat planes. Enter non-Euclidean geometry, which explores the nature of shapes and spaces that aren't flat. This might sound abstract, but it's actually closer to our real-world experience than you might think. Consider, for instance, the surface of a globe. If you've ever tried to flatten a globe into a map, you know it's impossible to do so without distorting some aspects of it. This is a glimpse into the peculiar world of non-Euclidean geometry. Non-Euclidean geometry plays a crucial role in modern physics. Einstein's theory of general relativity, which describes gravity as the curvature of spacetime, relies heavily on non-Euclidean concepts. So, when we talk about the cosmos itself, we're stepping into the realm of non-Euclidean geometry. In essence, geometry is the lens through which we can visualize mathematical concepts. It's a bridge that connects the abstract world of numbers to the tangible reality we live in. Whether it's the simple elegance of Euclidean concepts or the mind-bending abstractness of non-Euclidean ideas, geometry offers a unique perspective on the universe. Geometry, by offering a glimpse into the spatial structures of our universe, adds an extra dimension to the beauty of mathematics. Venture into the realm of algebra, the language of relationships and problem-solving. In the grand symphony of mathematics, algebra hits the right notes with its unique ability to express relationships and solve problems. It introduces us to the concept of variables and equations, a departure from the concrete world of numbers and into a realm where we can represent unknown quantities and relationships. Imagine a world where you could replace any quantity with a symbol, say X or Y, and manipulate these symbols to solve puzzles, or better yet, explain the world around us. This is the world of algebra. Here, equations act as a mathematical sentence, expressing relationships between variables and constants. They form the basis of a language that allows us to solve a wide range of problems, from the simple to the complex. But the story of algebra doesn't end there. It extends its reach into more abstract and generalized structures known as groups, rings, and fields. These algebraic structures take the concept of relationships to an even higher level. Groups, for instance, are sets of elements combined with an operation that follows specific rules. They crop up in a variety of places, from number theory to geometry, and even in the world of quantum physics. Rings and fields further expand this concept, adding more layers and complexity, but also more power and versatility. They serve as the backbone of many areas of mathematics and have profound implications in other scientific fields. One of the most intriguing applications of algebraic structures is in the world of cryptography and coding theory. The art of writing and solving codes, which is crucial in our digital age, heavily relies on the principles of algebra. From securing online transactions to encoding and decoding information, algebra plays a vital role in maintaining the privacy and integrity of our data. Algebra, by providing a framework for expressing relationships and solving problems, serves as a potent tool in the mathematical arsenal. So, next time you encounter a problem, remember, there's probably an algebraic solution waiting to be discovered. Dive into the world of calculus, the cornerstone of understanding change and motion. Imagine holding a magnifying glass up to a curve, scrutinizing it so closely that it begins to look like a straight line. This is the essence of differential calculus. It's about breaking things down to their infinitesimally small components, allowing us to understand how things change at an exact instant. It's like capturing a snapshot of a car's speedometer at a specific moment during a race. This can be used to calculate rates of change, slopes of curves, and other dynamic phenomena, providing crucial insights in fields as diverse as physics and economics. Now let's flip the magnifying glass. Instead of zooming in, we zoom out, taking in the whole curve. This is the spirit of integral calculus. It's about adding up an infinite number of infinitesimally small parts to understand the whole. It's like calculating the total distance a car has traveled during a race by adding up all the tiny distances it covered in each instant. This approach allows us to calculate areas under curves, volumes of shapes, and total accumulations over time. Together, differential and integral calculus form the two fundamental branches of calculus. They are like two sides of the same coin, offering different perspectives on understanding change and motion. While differential calculus focuses on the microscopic view, integral calculus provides the macroscopic view. But calculus isn't just about the abstract. It's a critical tool in many scientific fields. Physicists use it to describe the motion of planets and particles. Economists utilize it to model market dynamics and optimize business strategies. Engineers apply it to design efficient systems and predict performance. The applications are as diverse as they are profound. Calculus, by enabling the understanding of change and motion, opens up new avenues in the exploration of the mathematical universe. With every derivative calculated and every integral solved, we delve deeper into the mesmerizing world of mathematics, uncovering the patterns and structures that govern our universe. Witness the power of mathematics as it permeates every aspect of our daily lives. You might not notice it, but mathematics is at the heart of almost everything we do. It's in the algorithms that power our smartphones, our tablets, our computers. It's in the statistical methods that guide our scientific research, helping us to make sense of the world around us. Mathematics helps us to design and construct towering skyscrapers, to navigate the vastness of space, and to predict the patterns of the weather. It's in the financial models that fuel our economies, and it's the secret sauce behind the latest technologies in artificial intelligence and machine learning. It's easy to think of mathematics as an abstract concept, detached from the real world. But in truth, it's deeply intertwined with our everyday experiences. It's a tool, a language, a framework that helps us to understand and navigate the complexities of our universe. The practicality of mathematics, coupled with its abstract beauty, makes it an indispensable part of our modern world. Gaze into the future, where the mathematical universe continues to present challenges and frontiers. The journey is filled with unanswered questions, like those that linger in number theory. a branch of mathematics devoted to the properties and relationships of numbers. The mysteries of prime numbers, those enigmatic integers that have only two distinct positive divisors, continue to baffle and fascinate mathematicians. Then there's the exploration of higher dimensions, realms beyond our three-dimensional perception of the world. These dimensions, though abstract and seemingly unfathomable, could hold the keys to unlocking deeper truths about the universe. As the mathematical landscape expands, so does its complexity. But within this complexity lies an inherent beauty, a symphony of numbers, patterns, and equations that form the language of the cosmos. As we continue to probe the depths of the mathematical universe, we discover not only its intrinsic beauty, but also its profound interconnectedness with the cosmos.